Hello students, in this video you will learn about aldol condensation reaction. It is one of the most important reaction which is from the chapter called aldehyde and ketone. Let's first understand what is this reaction. This is a condensation reaction where the aldehyde and aldehyde or aldehyde and ketone or ketone and ketone or in short I can say where two of the carbonyl compound react in the presence of dilute NaOH to form beta hydroxy aldehyde and ketone. So here you can see the product is beta hydroxy aldehyde and ketone. As you can see here, here I have taken only aldehyde and aldehyde. This is aldehyde and this is also aldehyde. So the product formed will be aldehyde, that is beta hydroxy aldehyde. If I would have taken ketones here, that is this ketone and this would be a ketone, then only the beta hydroxy ketones would have been formed. Further, this reaction is followed by the heating of substance, or on heating it give you a product which are unsaturated, alpha beta unsaturated product. Look at this, alpha beta unsaturated products. So this is what this carbon is, alpha carbon, because this carbon is holding one group called functional group. So this carbon is alpha carbon and this carbon is beta carbon. Now the unsaturation will exist in between the alpha and beta carbons. So this is what this reaction is about. Now let us understand what you have to remember when you are talking about this reaction. First very important thing is that this reaction takes place in the presence of dilute NaOH. Second thing which you have to remember is कि this particular part of the reaction, that is the formation of beta hydroxyaldehyde or ketones. This is called as aldol reaction. Jabki the entire reaction, that is up to the formation of this compound, this reaction is known as aldol condensation. So hope it is clear to you. The formation of beta hydroxyaldehyde and ketone is known as aldol reaction, and the entire reaction which is giving you the formation of alpha beta unsaturated compound, this entire reaction is known as aldol condensation. Okay, now let us understand the mechanism of the reaction. So for that sake I'm writing down a formula of aldehyde, and as you can see here, this hydrogen, all three hydrogens are alpha hydrogens. So this reaction is all about the acidic property of the alpha hydrogen. So ultimately I'm going to remove any one hydrogen from these three because all of them are alpha hydrogen. But when it will happen? It will happen only in the presence of OH minus, as we have already discussed this thing, that this reaction takes place in the presence of dilute NaOH. So in the presence of OH ion, this alpha hydrogen will be removed, and now this aldehyde molecule will turn into a special molecule called, special ion called enolate ion, CH2 C double bond O and H. As you can see here, the entire molecule will remain same, but one H is removed by taking its electron from the carbon, and now this will turn into water molecule, that is OH minus will react with this H and will turn into H2O molecule, whereas this is a molecule, this is an ion called enolate ion. Now this is enolate ion. This ion is highly stabilized because of resonance. Let me tell you how. CH2, C double bond O and H. Here this double bond, it is shifted here, and now this can convert into another form where these electron will shift between the carbon and carbon, whereas this bond will shift to the oxygen, Hence, this shifting will give you another kind of ion, as you can see here, and that is CH2. The double bond will be formed, and the CO, and this will hold 2 electrons, and that way this shifting will take place, this to this, and again the bond will shift from this to this, and this will give rise to a structure which will be always resonating structure, and that is why this structure becomes very stabilized, highly stabilized. Now the enolate ion is formed. Now the second step we have to go for. So here I have written down the second step. In the second step I have written down here a fresh aldehyde, another aldehyde on which this enolate ion is going to attack. CH2, CH2 I am writing down here, and this is what? Enolate ion. Now just because this is minus, and this electron will get shifted to the oxygen, and these will attack on the carbon, as this carbon will acquire positive charge and oxygen will become negative. So the attack of this will be a nucleophilic attack, and afterward we'll get the product as, I'm doing nothing, I'm just writing down the things as such. Look at this, CH3. Now I'm writing down this carbon with the attack of CH2 connected together, and I'm going to shift this H to downside. So look at this, C, and to the right CH2, CHO, the entire enolate ion, but the charge is gone now, and this H is shifted to the downside, and O will remain as such. Now just because the electrons are there, this is going to be an anion. This is what an ion is formed, which is an intermediate for this reaction. Now in the third step we have to go for step number 3. So let's see what happens in third step. Now we have this anion, and this anion will be attacked by the H plus ion, so that the NaOH will remain as such, as it is working as a catalyst in the reaction. So let's see what happens in the last step. CH3C, this will be attacked by H plus ion, and you will get beta hydroxy aldehyde and ketone. So I'm writing down the things as such, making this, attaching it with the OH, O attached to the H. Now this is called beta hydroxy aldehyde, and just see why we are calling this as a aldehyde, beta hydroxy. This carbon is alpha carbon, we all are sure about, because this carbon is containing functional group. Near to this carbon, just after this carbon, we will have beta carbon, and the OH which is attached to the beta carbon is known as beta hydroxy. So this is why it is called as beta hydroxy, as it is aldehyde. So beta hydroxy aldehydes are formed. Now in the next step, if I heat this compound, now on heating this compound will turn into the alpha and beta unsaturated product. That is, you can see here alpha and beta. I'm removing OH from here, and I'm removing one H from here. So rest of the things you can write down as such. I'm writing down CH3, this one. Now attach it with the carbon and hydrogen. I'm writing down this hydrogen together with the carbon. Double bond, as the OH and H has been removed, so they will satisfy themselves by two of the bonds, C, H, which is left, one H is removed, and CHO. So you can see that alpha and beta unsaturated compounds are formed. So this is what the entire reaction is. The reaction from here to here, this is called aldol addition reaction, but the reaction from this to the formation of this is known as Aldol condensation reaction, as the condensation is the mixing of two substances with the elimination of simple molecules like water molecule. Okay, now let us talk about the variation of Aldol condensation reaction, and that is called Claisen condensation. In this condensation also we can have aldehyde and ketones, but it is the condensation between the aromatic aldehyde or ketone with aliphatic aldehyde or ketone, and obviously aromatic aldehydes will not be having any alpha hydrogen, so they will not be attacking to the aliphatic aldehyde or ketones, but aliphatic will attack always, that is they are going to make the enolate ion. So this is your benzaldehyde which is having no alpha hydrogen. So this is not going to create any enolate ion. So this will not produce enolate ion. But here this aldehyde which is containing alpha hydrogen, this is going to create enolate ion, that is, it is going to form CH2 CHO with the elimination of H plus ion, and this is going to attack this carbon as it will shift its electron to this, that is there will be double bond between the oxygen and this hydrogen will be, I'm making it here, the shifting of carbon to this oxygen, making it positive slightly, making this negative slightly, and the attack will take place here. This will join in this manner, and this O will be connected later on with the H, and this reaction also takes place in the presence of dilute NaOH. So basically it is a it's a variation of aldol condensation reaction. Here also aldehyde and ketone reacts, but you have to remember here it is between the aromatic aldehyde or ketones or aliphatic aldehyde and aromatic aldehyde with aliphatic aldehyde and ketones. So I hope it will be helpful for you. Thank you.